that's why we have these kind of things, because for undergraduate fluid mechanics laboratories, we have people measure that gradient, and you can calculate flows based on it. And then you get an additional gradient over these bed forms because of this flow variation over the top. So you get this difference of pressures, one from the slope of the river flow, and the other one because of the interaction with the boundary. That's another kind of dye injector. So over there, you see those like white shapes? You actually can put in airfoils or other shapes and you can inject dye over them. So you can take out that piece, you can insert something, which would be like a piece of a wing or a sphere or a cylinder, a rod, and you can do measurements over that. So these devices are very flexible for different kinds of experiments.
Water getting pushed at the top or throughout the entire lab?
So that has a different design too. That actually has what's called a submerged sluice gate. So the water is pumped and then it builds up in that reservoir and it flows underneath. Now normally for this kind of experiment we just raise that up so it just flows over the top. But you can also use that to make a thin sheet of water that comes out at the bottom. So that's for another kind of typical experiment. But if we did that with that submerged sluice gate with a very narrow sheet at the bottom where the water's coming out, it would carry away all the sand, which we don't want. We have it set up to run just as a flow over the sand bed here. So do you guys have other questions? Or do you have particular interests with regard to environmental engineering, environmental science, river processes? What are you interested in?
I think I'm a little bit environmental.
Yeah, that's good. Well, there's certainly a lot of work that needs to be done. I just came back from a national water conference. So drought this year, is really bad. So like 70% of the U.S. is in drought right now. A lot of places don't have enough water, so there's a lot of interest right now in just water sustainability, water resources issues. And this is tied to things like food production. So because of the heat and the drought, it's already estimated that 75% of the corn crop in the U.S. probably will be lost now this year. And this has already greatly increased food prices. And there's big issues, not so much here, but places like California and the southeast U.S., a lot of the west, the mountain west region, about making sure there's going to be enough water for people to use. And another aspect of what we do here is it's not only the volume of water that's important, but you also have to make sure that it is of sufficient quality to be useful. So you have these issues, increased evaporation, increased use for agriculture, return of contaminated water leads to salinization, right? Increased saltiness, decreased quality. And there's a big push to make sure we understand how water's moving around, what are the supplies going to be, make sure that they're secure and sustainable, right? So we take water out of the environment, use it, return it, and make sure that we don't degrade the systems too much. And also to make sure that the natural aquatic ecosystems will still be functioning long term. Right? So it's big issues this year, especially with all the heat and drought.
If I can just add also as a personal strategy, this is one of the fastest growing employment sectors. So it's a good field to go into at your age, because there's definitely a big need for people working on water for the reasons that I've just mentioned. This is a lot of fun.
So one thing that we're trying to do, historically you had separate like biology, chemistry, physics, engineering, environmental engineering, but it's recognized a lot of these problems involve all of that. So a lot of the focus is on integrated understanding of environmental systems. So does anybody have interest in like just physics, chemistry, biology? Yeah, most of you guys. So is your view currently that you can just work on, say, biology or chemistry, or do you really have that integrated view? So you do appreciate that? Yeah. Triple majoring, okay. Well, that's good. So yeah, we're definitely looking for people that can link natural sciences and engineering. and that have things like an appreciation of biology and ecology, but also quantitative skills to generate predictions, forecasting models for these really big, large-scale environmental phenomena. Right, so we should look again at the dye injections, because you should see that they moved quite a bit for whatever. They've moved a lot more on this side than the other side.
Is it because we're in a bigger dip?
Yeah, so actually the flow that you get of the subsurface depends on the extent of variation in the surface, like the height of the dunes. So here you can see at this location they moved quite a bit and it propagated downward and it was following that. And on the ones upstream really haven't moved very much. So at least you can see there's some variability that things really are moving. And you can imagine if they're contaminants, they would be flushed out at different rates, a little bit hard to predict. And if you're thinking about something that's growing in the subsurface that needs nutrients that come from the water column, there's quite a bit of variability in habitat conditions as well. I'll have to find a better spot for the next time. Yeah, you can see, you guys maybe should come around, because on this side I put the same dots, and you can see that this has moved quite a bit. And this follows, if you saw some of the simulations, the patterns that were predicted there. And the other one, you can see that this has moved, and that these are pretty stagnant. So there are places I mentioned that are known to be stagnant. See, this can move a lot more than the other side. They start off just the same. So did you see the simulations?
It's one way of
So what we do also for undergraduate
studying for the
classes,
next round.
we put in these spots of dye and we take a series of photographs of them, and then we have people compare them against the model. So then you can really see. By eye, you can tell they're changed, but generally our brains aren't so very good at like remembering the sequence. So you can see the pattern much more. So at least you can see that this pattern shows the streaks that are very typical that the dye that was in dots gets smeared out as it flows along.
I actually brought a Sharpie, but I guess too late for this one.
Oh yeah, we can do quite easily. Just circle the original positions.
I'll do a few, so the next one's gonna save.
Yeah, we don't know the timing. So,
What time is it?
do you guys have another tour after this? So, is there another group coming too?
Yeah, someone's gonna go fetch them from their lab, and they're gonna be up here in probably about 5 minutes.
Okay.
I'm pretty sure they do. There's also a leak here, I don't know.
I think that was just from the hose. So one thing you can see if you work in a lab like this, eventually you get wet and dirty.
Yeah, it's a wet lab.
Yes, in fact, that's how we describe them. It's a wet lab. Alright, you guys have any other questions? Or other things you're interested in hearing about? Let's see, other things I can show you?
Can you see what happens when you open up the wall?
The gate?
The gate?
Let's see. I have to see how it's. Well, so you can kind of look at it. So it is quite open. It's probably more interesting if I ratchet it down.
Yeah,
Oh,
you can
is
see
it
all that
halfway
sand
right
like.
Is that halfway right now?
Yeah, it's about halfway of that.
So
Which
way is it coming?
Oh, yeah.
Is that going up?
Oh yeah.
Definitely it's going up.
Yeah.
That's up.
So what will happen is I close this down. Because it's pumped, it's still moving the same volume of water around over time. And it's forcing it through a thinner slot. So the velocities have to go up. And as that impinges on the sand, it should start moving it quite a bit.
That's moving it up.
Oh, that's moving. Oh, sorry. You have to tell me when it's getting close, because I don't want to shut it off.
Oh, it's moving now. There you go.
Yeah, like an inch.
Oh, that's too much. Yeah, so it moves the sand quite a bit.
I'll put some dye in there.
Alright, I don't think I have enough dye, but it'll just go really quickly over the top of it.
Oh, yeah.
You see?
Looks like someone's gonna put sand bags
So
in
you
there.
can see this sand is in fact mobile, and when you have water directed on it, it moves really readily and then it piles up, so it makes even a bigger.
I don't know if you guys heard, but that's what they do in the Grand Canyon to build up the beaches because of the tourism, right? So they just open the gates of the dams to like flush the sand from the bottom of the river and put it back on the basically campsites, so they can build like campsites for people. So that's exactly what we just saw.
Sandbars.
Sandbars, yes.
So we can take that down and make a really, really thin slot, and it'll make this really fast jet of water that goes out. And you can generate a lot of turbulence that way. So it's used without the sand bed here, just to study fluid flow turbulence properties. Right? So these are the kind of things that are used in undergraduate fluid mechanics courses and some environmental courses. So this, in fact, is our undergraduate environmental fluid mechanics lab, and the other half of the lab has a lot of equipment for more basic fluid flow or industrial sorts of applications, pipe flow. Right? And this process that you see with the sand moving around in response to flow is going on in all the major rivers everywhere, basically. So this is the process that's responsible for forming the structure and morphology of the systems and for moving sediment basically from the mountains out into the oceans eventually, which takes hundreds of thousands of years. But it's going on everywhere all the time, and it's been studied for a long time just in terms of the physical processes, and we're really trying to link it to things like contamination and ecological processes.
What does the filter do with this?
So you can also see,
What does the filter do with this? Like,
when you
with all
see the
sand?
sediment transport, it's
Just
another
go back down.
mechanism. So
Yeah, there's actually
cut off-
no filter, so sometimes we do put like a little mesh at the end so that the sand doesn't flow too much through the piping. But otherwise it just collects basically in that big container there. It just falls down and collects, and the pump itself is a little above, you know, the bottom, so it doesn't suck up all that sand. But there are some flumes, like when you're really interested in like sediment transport, basically, there's some flumes that are equipped with like special equipment to actually move the sediment back upstream and kind of recirculate the sediment.
yeah.
But this one is not one of those.
Yeah, so the reason that we don't want to move too much sand here is because there's no mechanism when the sand gets in that big reservoir down there to have it come back up.
Right. So it's
Right.
not meant to do that. So basically the sediment goes through the pump, which is not very good in this case.
Well, it will. I mean, these pumps are designed to have the sediment go through it. So the other designs we have, they just recirculate the sediment. In this one, it piles up on the end and we have to scoop it out. So it's really because of the reservoir there and because of this big tank here, it doesn't recirculate the sand very well. Okay. So do you know where you're going?
We're gonna go